Hello students, in this class, today we are going to solve SSLC Model Question Paper 1 for the year 2025-26, which has been released by Karnataka School Examination and Assessment Board for the subject Science. Here you can see the time allotted for this paper, it is 3 hours 15 minutes and the maximum marks is 80. This paper consists of three parts. First part will be of physics, part B will be of chemistry, and part C will be of biology. Total questions will be 38, and these questions are divided into 5 sections. First section consists of multiple choice, and remaining all 4 sections consist of theoretical questions of different marks 1, 2, 3, and 4 mark question. So without wasting much time, we are going to start with our first section, that is multiple choice question. So we'll start with part A, that is physics, and section 1 is 4 alternatives are given for each of the following questions or incomplete statements. Choose the correct alternative and write the complete answer along with its letter of alphabet. So this is multiple choice section, and where 2 questions will be there. Each question will carry 1 mark. So total marks for this section will be 2. So the first question is, the SI unit of potential difference is. You have to write the SI unit of potential difference. So here the correct option is option A, that is volt. So the reason is, what is potential difference actually? It is the work done to move a unit charge from one point to other point in an electric circuit. So in any electric circuit, from one end of the wire to the other end of the wire, if you want to move a unit charge, then whatever work done will be done, that is called as potential difference, and which is also known as what? Voltage. So here the potential difference between the 2 points is work done divided by charge, that is W divided by Q. W is nothing but the work done and charge is nothing but Q. And that's why the formula of this potential difference here, it is V is equals to W by Q. So the correct option for this question is option A, that is volt. So we will write the answer. Answer, that is A. And this is your option. Now here only you can write your answer also, that is volt V. So this is the answer for our first question. Now we will see the second question. So the second question is, the reciprocal of focal length of lens is. Focal length is nothing but F. So if you take a reciprocal of focal length, then it is called as what? So this is the question. Actually here the answer is option A, that is the power of a length. So you can see here, the reciprocal of a lens's focal length is its power, which is a measure of how strongly the lens converges or diverges the light. That is called as power. Power is denoted by the letter P, and power is nothing but 1 by F. F is focal length. If you take a reciprocal 1 by F, then it will become a power. And that's why the correct answer is our option A, that is the power of a lens. We will write the answer. So write down answer. Option A, and in front of this only you write down the answer, that is the power of length. Always remember, you have to write the option, either it is A, B, C or D, and then in front of that you have to write the answer also. Now we'll move with the next. Now we'll start with section 2. Answer the following questions. Question number 3. Write the symbols of the following components used in the electric circuit? So here they have given some components and we have to write the symbols for those components. First one is dry cell and second one is rheostat. So you can see the answer. In an electric circuit, the symbol for dry cell is represented by two parallel lines of unequal length. In any electric circuit, you can see two parallel lines which indicates battery. So here, or a cell. So here these two parallel lines which where one line will be little bit big and the second line will be small. You can see in the symbol here. This is a big line and this is the small line. So big line indicates positive terminal and small line indicates negative terminal of the battery. So this is the symbol for dry cell. Second one is rheostat. So rheostat is a variable resistor used to control the flow of electric current in a circuit. If you want to control the electric current, the flow of electric current into the circuit, you can connect a variable resistor. Variable resistor means what? The resistor whose value varies. That is called as variable resistor. And the symbol for this is the given which is here. Either you can draw this symbol or you can draw this one. Both are correct. So now we will move with the next question. So the fourth question is, observe the below figure. When switch is closed, does the B end of the solenoid attract N end of the bar magnet? Clarify the answer. So here what you have to do, observe this figure which is given, and in this figure they are asking when the switch is closed. Now here if you see this switch is open actually. Now here current cannot pass from one end to another end of the wire. But they have asked if the switch is closed, then does this B end of the solenoid attracts N end of the bar magnet? This is the question, and then you have to explain your answer. You have to give the reason for your answer. So we will solve this. So see the answer. We will label first. So this is the diagram for solenoid and this is the diagram for bar magnet. Now see, in this solenoid, here it is a cell and in this cell this is the positive end and this is the negative end and this is the switch. Now the switch is open and but they have asked if it is closed. So now I will close it. See, now the switch is closed. If the switch is closed, now the current can pass into the circuit. So when the switch is closed, now when the battery is on, current will pass like this in this direction. This is the direction of the current. So when the current enters into the solenoid, what is the direction of the magnetic field lines? That we have to find out. And that we can do it by using right hand thumb rule. So according to right hand thumb rule, you can see this diagram. According to right hand thumb rule, thumb indicates the direction of the current and remaining all curled finger indicates the direction of the magnetic field lines. So according to this rule, the direction of the solenoid from where the current is entering, that will act as south pole, and the other direction, other side of the solenoid will act as north pole. So here once the current enter into solenoid, this whole solenoid will act as one more bar magnet. So this also will act as a bar magnet, and for this bar magnet, now this side, this end is south and this other end, that is B end, will be north. Now in such condition, if we bring this bar magnet near to this solenoid, now what happens? You can see this is a north pole of solenoid and this is the north pole of bar magnet. So we have already studied in our lower standard, that is like poles of the magnet always repel and unlike poles always attract. So these both are like poles, north, north. So when they come close to each other, they will always repel. So here the B end of the solenoid will repel the north end or N end of the bar magnet. So that is the answer for this question we have to write. So answer, no, B end of the solenoid repel the N end of the bar magnet. And as they have asked, clarify the answer, you have to explain it. You have to explain your answer. You have to give the reason. So what I have done, so you can write according to right hand thumb rule. So explain your right hand thumb rule here. Write down the right hand thumb rule. If you are holding a current carrying conductor in your right hand, such that thumb points the direction of the current and then your fingers will wrap around the conductor in the direction of the field lines of the magnetic field. That is nothing but here what we have seen, like poles of the magnet always repel and unlike poles always attract each other, and because of this only the N end of the solenoid will repel the N end of this bar magnet. So now we are going to see section number 3, that is answer the following questions. This section consists of 3 questions and each question carries 2 marks, so total marks will be 6. So we will start with 5th question. What precautionary measures have to be taken to avoid overload in domestic circuit? To avoid overload in domestic circuit, what precautions we have to take, that we have to answer. So here you can see, first we will see what is overload. Overloading can occur when the live wire and neutral wire come into direct contact. So here you have already studied the electric circuit in domestic. So in electric circuit, in domestic electric circuit, we can see there will be one live wire and also there will be neutral wire. So if these both the wires comes in contact, directly if they come in contact, then overloading will occur. This occurs when the insulation of wire is damaged or there is a fault in the appliances. So another way is what for overloading? So it is if the insulation of wire is damaged. So what is insulation? For every wire, imagine if there is a copper wire, for that copper wire there will be covering of different colors. So you maybe have seen the wires of red color, black color, blue color, even green color. So for copper wire there will be one insulation coating from the outside, and if that insulation get damaged, then also overloading can occur. Even if there is a fault into the appliances, whatever appliances you are connected into the circuit, if there is a fault in those appliances, then also we can see overloading. In a situation, the current in the circuit abruptly increases. So if you connect some faulty appliances, or if there is a damage in insulation, or if live wire and neutral wire comes directly in contact with each other, then suddenly the current into the circuit increases, and that is only called as short circuit. So this is about overloading. Now what are the precautionary measures? What we can do to avoid this overloading? So first one, the use of an electric fuse prevent the electric circuit and the appliances from possible damage by stopping the flow of unduly high electric current. The Joule heating effect that produces it melts the fuse to break the electric circuit. Means what? Here what we have to do is, in your electric circuit we have to connect a fuse. So what this fuse will do, if there is a high electric current flowing into the circuit, due to Joule heating effect, the metal which is present in the fuse that will get melt, and if it get melt, it blocks the circuit and current will not pass forward, and due to this whatever appliances are connected into the circuit, all will remain safe. So what they are saying is, actually main thing is the metal present into the fuse is lead tin alloy. This is the alloy which is present into the fuse. What is alloy? Alloy means mixture of two or more metals or non-metals. So here we have used lead and tin, and by mixing those, whatever alloy we have prepared, that we are using in this fuse. So what this fuse will do? Now imagine this is the circuit, this is a wire, and here you are connected your fuse. So this is fuse, and in front of this you have connected your appliances. So these all are your appliances. Now see, from this side, if the sudden high voltage current comes, due to this high voltage current, first it enter into the fuse, and due to the Joule heat effect or increase into the temperature, increase in the heat, the alloy which is present here, that will melt, and because of melting, this whole area here, it get blocked, so it blocks the passage. So whatever current is coming, high voltage current is coming, it will not pass to these appliances. So these all the appliances will remain safe. So this is the first precautionary measure. Now we'll see the second one. More than one appliances should not be connected in one socket. Now you maybe have seen there will be many sockets in your house. So for one socket, you should not connect more than one appliances. Means in one socket you should not connect your mixer, you should not connect your mobile charger, even you should not connect the TV, etc. So that should not be done because every appliance require a different amount of current. So that you have to avoid here. Third precaution, in order to get equal potential difference for each appliances, they should be connected parallel to each other. So in parallel connection, if you take a parallel connection, then the potential difference allotted for every appliances will be equal. There are two type of connection. One is series and one is parallel. So in parallel connection, equal potential difference will be supplied. Therefore, always appliances should be connected in parallel. Fourth precaution is, precaution should be taken that live wire, neutral wire should not come in contact with each other. So as we have discussed here, what is overloading? So overloading can be caused by the live wire and neutral wire when they come in contact. So you have to avoid that. So that was the fourth one. Fifth one, ensure your home has proper earthing, that is green color wire, so that excess current has safe path to flow through the circuit. So what is earthing? Earthing means there will be one green color wire into your domestic electric circuit. There will be one green color wire in your circuit in a house. That wire will directly go into the earth. So whatever extra voltage comes, that will directly pass into the earth. So that is called as earthing. And that earthing should be proper in the house. And the sixth one is, faulty appliances should not be connected into the circuit. So if the appliances is not good, if there is a fault into the appliances, such appliances should be avoided connecting into the circuit. So these are the six precautionary measures that should be taken to avoid overloading. So here this question is of 2 marks. So at least 3 precautionary measure you have to write in your answer. Now we'll see the next question. So now the sixth question is, mention the factors on which resistance of a conductor depends. So we have to write some factors on which resistance of a conductor depends. So before writing the factors, first we will see what is resistance. It is the property of a conductor to resist the flow of charges through it. So it is the property of a conductor. Resistance, it is the property of a conductor which resists, which will not allow the current to flow through the conductor. That property, it is called as resistance, and its unit, SI unit, is ohm. So here we have to write the factors which decides this resistance. So which are the factors? So here you can see, first factor is length of the conductor. So whatever conductor you are using, the length of that conductor, it is the important factor. So how it relates or how it is affected, resistance is directly proportional to the length. So you can see here, resistance is directly proportional to the length. Directly proportional means what? If the length increases, resistance also increases. It is called as directly proportional. If the length decreases, resistance also decreases. Second one is area of cross section of the conductor. So length means like this, and the area means thickness of this wire. So here let me draw. So here you can see, if this is the wire, then this is called as length of the wire. So this whole area is called as length. So if the length is more, resistance will be more. If the length is less, like this, then the resistance will be less. That was the first factor. Second is area of cross section. What is the area of cross section? This is called as thickness of the wire. So if you see from this side, whatever thickness of this wire you can see, that is called as area of cross section. So how it depends on area of cross section? Resistance is inversely proportional to area of cross section of the conductor. So you can see here resistance is inversely proportional to area of cross section. Means what? Inversely means if the area of cross section increases, resistance decreases. This you have to remember. If the area of cross section increases, then the resistance decreases. This is called inversely proportional. Third factor is nature of the material of conductor. So here it is the nature of the conductor. Conductor is made up of which type of material, on that also the resistances depend. The metal and alloys have very low resistance. See here I have written metals and alloys. What is alloy? It is a mixture of two or more pure metals or non-metals. So we have seen just now in the last question. So here metals and alloys have very low resistance. So here the current flow will be good, faster compared to insulators like rubber and glass. So we know rubber and glass will not conduct electricity. Why they will not conduct electricity? Because they have high resistance. So depending on the nature of the conductor, resistance will be decided. And the next last factor is temperature. Resistance is related to the temperature differently depending on the material like metals, alloys, insulator, etc. Means it is depend on the material as well as is depending on the temperature. So both will decide, temperature and the nature will decide the resistance. So these are the four factors on which resistances depend. So these are the four factors which you have to write into the answer. Now we'll see the next question. So the next question, question number 7. Observe the given figure below. Name the angle of deviation and identify its value. So this is the diagram which is given, and we have to name the angle of deviation, find out angle of deviation, and then we have to write its value also. So before going to find the angle of deviation, we will see what is that angle of deviation. It's the angle between the incident ray and the emergent ray. Incident ray means the ray which is falling on the prism. So here this triangle is prism. It is written already, glass prism, and this is the incident ray. You can see the arrow. So this is the ray which is coming and hitting on this prism, incident ray, and emergent ray is the ray which is coming out of the prism. That is called emergent ray. So now it is the angle between the incident ray and the emergent ray. If we extend the incident ray forward, so this is the incident ray till here it is. Now we are going to extend it. So dotted line, this you can see it is called extension of incident ray forward, and the emergent ray backward. So this is the emergent ray here, and this if you extend backward like this, you can see this dotted line. So this, then the angle where they meet is called angle of deviation. I hope you are understanding. So just see here, this is our incident ray. Then here it hits the prism, and then after this we have to extend it further. So this is called extension of incident ray. And here this is our emergent ray, and this we have to extend backward. So backward means this side. So this dotted line is extension of emergent ray. This both line will intersect here, and this is the angle which will form. So the angle H, this is G, and this is F. So angle HGF, it is called angle of deviation. So here I can write, here the angle of deviation is angle H, G and F. This is angle of deviation. And what is its value? You can see here it is given 38 degree. So its value is 38 degree. So I hope you are understanding. I am explaining it in very simple way. So understand its value is 38 degree and the angle is HGF. We'll move with the next question. So now we will see section 4. that is answer the following questions. Here we have to answer three questions. Each question carries 3 marks. So total marks from this section, that is 9. Question number 8 we will start. It consists of two parts, part A and part B. So we will start with part A. Mention any two symptoms of myopic eye. How can this defect be rectified? So first we have to write the symptoms of a myopic eye, and then we have to write how it can be rectified, means how it can be corrected. So what is myopia? Myopia is also known as nearsightedness. Means what? The person can see the nearby object clearly, but it cannot see the distant object clearly. That is called nearsightedness. In myopic eye, the image of a distant object is formed in front of the retina and not at the retina itself. Means what? In a normal eye, the image is formed on the retina. So here you can see this is the eyeball, and in this eyeball you can see this red dot. So this area it is called as retina. So if the rays comes and meet on this red dot, that is called as retina, then you can see the object clearly. But in myopia, in myopic eye, the image will be formed in front of the retina. So the image will form here, and therefore which cannot be detected by the optic nerves which are present in the ciliary muscles or the eye muscle. So that is the reason which we cannot see the far object clearly. So this is the diagram for myopic eye. Now what are the symptoms? What we have to write? The first symptom is, as I told, the person with myopia can see nearby object clearly but cannot see distant object clearly. This we have to write the first symptom. Second, the person who has this defect will be having blurry vision for distant object. Means some people will not see the distant object, and some people we see the blur vision, blurry, the vision or the image will not be clear. Third one is headache and eye strain. Means the people who is giving stress on the eyes to see the distant object clearly, which leads to headache. And these are the three options, three symptoms of this myopia defect. What are the reasons for this? So the reason is, first one, excessive curvature of the eye lens. If the eye lens, this is called eye lens, if the eye lens has more curved or curved more, then also this defect can occur. And the second one is elongation of the eyeball. So this is your eyeball. If it gets elongated, then also this defect can occur. So these are the reasons for this defect, and then we will see the correction and how it can be rectified. This defect can be corrected by using concave lens of suitable power. So we are going to use concave lens of suitable power. This lens will bring the image back on the retina, and thus the defect can be corrected. So you can see this second diagram. In front of the lens we are using concave lens. So this is concave lens. So here what happens, when the light rays fall on this concave lens, first they will get diverged. They will go far. And after getting diverged, now they will come and fall on the eye lens. And after refraction, the image will correctly fall on the retina, which can be detected by the optic nerve. And like this, we can correct the myopia or the myopic eye, myopia defect or the myopic eye. So here they have asked symptoms and rectified. Rectified means correction. So here I have given three symptoms. Try to write all these three symptoms, which are very easy, and we have to write this correction. Even the diagrams are very important for the answer of this question. Now we'll move with the next question. Now the next is B from earlier question, that is 8th question. What is the power of accommodation of eye? Means our eye can see the objects which is present on the nearby or the far. So how it will accommodate eye lens, or how it will accommodate, how it will adjust the lens of the eye so that we can see the object present on both nearby as well as far distance. So the ability of the eye lens to adjust the focal length is called accommodation. So our focal length will be adjusted to see the object present on near or far distance. So what is the first point you are going to write? When the muscles are relaxed, muscles means the ciliary muscles which are present in the eye. When the ciliary muscles are relaxed, the lens becomes thin, due to which the focal length increases and enable us to see the distant object clearly. Opposite to this, when you are looking at the objects closer to the eye, the ciliary muscles contract, and because of this contraction, the curvature of the eye lens increases, due to which the lens becomes thicker. Earlier the lens becomes thin, now the lens becomes thicker, and this leads to increase the focal length, and which will enable us to see the nearby objects clearly. So you have to remember here the main points. So what are the main points? Ciliary muscles relaxed, and here the ciliary muscles contract. And then the second one is what? Lens becomes thin, and here the lens becomes thick. Third point is what here? That is focal length increases, and here the focal length decreases. So write these all 3 points, the answer will be exactly correct. So this is the answer for question B from 8. Now we'll move with the next question. Now the next question, question number 9. Explain an activity obtaining magnetic field lines around a bar magnet using compass needle. So this is one of the activity which is present in NCERT book. You maybe have seen this diagram in your note textbook. So this activity we have to explain in detail. So what is the aim? First we will write the aim of this activity. Aim is nothing but our question. Obtaining magnetic field lines around a bar magnet using compass needle. And what are the apparatus we require for this activity? Paper, bar magnet, compass needle and pencil. What is compass needle? Compass needle nothing but a circular object which has a needle shaped magnet inside. So how the compass needle look? It will be in a circular shape, and inside this there will be again small needle shaped magnet like this. So here also one side will be north and one side will be south. So like this there will be compass needle. Now we will start with the procedure. First step, take a small compass and bar magnet. Place the magnet on the sheet of white paper and mark the boundaries of the magnet. So we have to take one bar magnet. You can see this diagram. Take this bar magnet, place it on the paper. So this is, imagine this is one of the paper, and draw the boundaries of this bar magnet. Then second step, place the compass near the north pole of the magnet. So here you can see this is the north pole. So this is the north pole of the bar magnet and this is the south pole of the bar magnet. We will keep our compass near to the north pole. Now see what happens. Already compass is having one needle shaped magnet. So as this is the north pole of the bar magnet, south pole of the compass needle will get attracted and north pole of the compass needle will go away from this north pole of the bar magnet. Now mark these points south and north of this compass needle. You can see the points which I have written here. Place the compass near the north pole of the magnet. The south pole of the needle points towards the north pole of the magnet and north pole of the compass is directed away from the north pole of the magnet. So north pole moves away and south pole comes towards the north pole of the bar magnet. Mark the positions of two ends of the needle. Now we will mark both north as well as south. Now move the needle to a new position. So take this compass and move to the next position. Again here north and south pole will be adjusted. You have to mark those both. Again move to the next position and mark those both, and like this repeat the whole procedure. Now see the next point. Fourth one, join the points marked on the paper by a smooth curve. Now remove this needle and join these all the points which we have marked on the paper to get a smooth curve. This curve represents a field line. So this line, this curve is nothing but a magnetic field line. Repeat the above procedure. These lines represents magnetic field around the magnet. So repeat the same procedure again. Now what you have to do? Now take your compass needle here and go on repeating the same procedure. You will get one more line like this. Now keep the same magnetic needle on the other side of the magnet and you will get one more curve like this. Again one more line like this. And the diagram will again look like this itself. So these lines, these blue color lines are called as magnetic field lines. And this is only the answer for this question. We'll move with the next question. The next is OR question, that is explain the experiment that shows current carrying conductor when kept in the magnetic field experience a mechanical force. So here again we have to explain one of the activity from the NCERT book. So here what we are going to do, we are going to take one current carrying conductor and that we are going to keep in a magnetic field which will experience a mechanical force. So write down the aim is nothing but the again question, and then write down the apparatus. What are the apparatus we require? We require stand, we require one horseshoe magnet, wire and aluminum rod. So you can see this diagram, this is a stand, this is a horseshoe magnet, then we require this wire you can see to complete the circuit, and then we require one aluminum rod. So this AB which you can see, this is called as aluminum rod. So what is the first step? Take a small aluminum rod AB using two connecting wires, suspend it horizontally from a stand as shown in the diagram. So take this aluminum rod and connect with two wires. This is one wire and this is one wire, and suspend it horizontally with the help of this stand. Now the next is place a strong horseshoe magnet in such a way that rod lies between two poles with the magnetic field directed upward. So you have to take one horseshoe shaped magnet and you have to adjust in such a way that magnetic field line's direction should be upward. Means what you have to do, you have to place your horseshoe magnet like this. So this should be the north pole and this should be the south pole. So that magnetic field line direction should be upwards like this. So this is the direction of magnetic field line from north to south pole. And in between these two poles you have to keep your aluminum rod like this. So now the next, that is, for this, put the north pole of the magnets vertically below and south pole vertically above. So as I told, north pole is below and south pole is above. Now the next point. Now pass a current through aluminum rod from end B to A. Now this wire is connected to the battery as well as switch. Once we on the current, try to pass the current from B to A. So you can see the direction. So current is moving like this. So current will move like this, and first it will enter into B end, then it moves from B to A end. It is observed that the rod is displayed towards left. So when the current is moving from B to A, the force will be occurred on this rod, and that due to that force the rod will move towards the left, so it will move inside the horseshoe magnet. Now the next is reverse the direction of the current flowing through the rod and observe the direction of displacement. Now towards the right, it moves towards the right. So here what happens, now what you have to do, change the direction of current. Earlier it was moving like this, now you change the direction of the battery and try to move the current like this. So once if the current comes like this, it will move from A to B, and now the rod will displace towards the right side. It will displace out of the horseshoe magnet, and this is due to Fleming's left hand rule. This whole activity can be explained by using Fleming's left hand rule. So what the rule says? According to this rule, stretch thumb, forefinger and middle finger. So see this diagram here. So this is thumb, this is forefinger and this is middle finger. So all three we have to stretch such that they are mutually perpendicular. Means the angle between the every two fingers should be 90 degrees. So all should be perpendicular to each other. If the first finger points in the direction of magnetic field, so first finger points the direction of magnetic field, the second finger points the direction of current. Means here middle finger is pointing the direction of current, then the thumb will point the direction of motion or the force acting on the conductor. Then the thumb will point the direction of motion or the force acting on the conductor. So here thumb will tell the direction of force. So if we hold our left hand, these three fingers in front of this activity, we can easily understand which side the aluminum rod will display. So this observation can be explained by Fleming's left hand rule. So this is the answer for this question. You have to draw the diagram, you have to write these all the steps, and even you have to explain or you have to write Fleming's left hand rule for this answer. Now we'll move with the next question. Now the next question is question number 10. Draw a ray diagram to show the image formation when object is kept beyond C in front of the concave mirror. When the nature mention the nature and position of the image formed. So here we have to take a concave mirror. So you can see this is our concave mirror and the labeling are M and N. So this is concave mirror and we have to keep our object beyond C, means back side of the C. So here you can see this is C, center of curvature, this is F, focal length, and this is our pole. So I have kept the object, that is AB, beyond C. So the light ray which is coming parallel to the principal axis, that will go and hit the mirror, and after reflection it will pass from the focus. Then the ray which is coming from the center of the curvature, it will hit the mirror, and after reflection it will goes back in the same direction, and the reflected rays will intersect at the point called A dash. Here you can see this point of intersection A dash. So if we draw our image here, so A dash, B dash, this is the position of the image. So this is the diagram, ray diagram for the object when we kept it beyond C. And in this case, they have asked to write the nature and the position. So what is the nature of the image? Our image is real because it is forming in front of the mirror, same side from where the light rays are coming. So this is real. It is inverted. So see the object. Object is AB and your image is downside. So it is inverted. And even it is diminished. Diminished means small. Compared to our object, our image is small. So that's why diminished. What is the position? The position, our image has been formed between C, center of curvature, and focus, that is F. So this is the position of the image which is formed. So you have to draw this diagram and then you have to write nature and position for this answer. We'll move with the next question. Now we are going to solve section 5. Answer the following questions. And here we have to answer 2 questions. Each question carries 4 marks. So total marks for this section will be 8. So the question number 11, it consists of A and B part. So the A question we will solve. Observe the below table. So this is the table which is given. Which of the below listed electrical appliances consume more energy? So you can see the table. So here they have given electrical appliances, that is one is TV and one is toaster, and then electrical power is given, that is P is given. For TV it is 250 watt and for toaster it is 1200 watt. Then time is given, time of use. For TV it is 4 hours and for toaster it is 1 hour. We have to find out how much, we have to find which of the below listed electrical appliances consume more energy, means which appliance will consume more energy. So we have to find out the energy first. So first we will start with, that is TV. So write A for TV. So what is given? So we will write given. So we have power, and the power for TV it is 250 watt. So write down 250 watt. Then we have time, that is T is equals to 4 hours. So write down 4 hours. and we have to find out energy, that is E is equals to question mark. So what is the formula we can use? So E is equals to, we can write power, that is P, into time, that is T. So substitute the value. So what is the power? It is 250 watt, into time is 4 hours. So I'll write 4 hours. So you multiply 250 into 4, we will get 1000, and this will be watt hour. But we have to convert this watt hour into kilowatt hour, and therefore I will write it here for kilowatt hour. So now what you have to do? Energy is equals to 1000, which we have got earlier, and we have to divide this answer with the 1000. So now whatever answer we will get, this answer will be in kilowatt hour. So here zeros and zeros will be cancelled, and the answer will be energy is equals to 1 kilowatt hour. So this is the answer for TV. So the energy consumption for TV is 1 kilowatt hour. Now we will solve toaster. So B, I will write here toaster. So for toaster, what is given? So here P is equals to 1200 watt, 1200, and time is, that is 1 hour, and we have to find out E, that is energy, question mark. So now use the formula. So E is equals to, already we have wrote the formula here. So what is our power? Power is 1200 watt, into time is what? 1 hour. So the answer will be 1200 watt hour. Again, for kilowatt hour, divide this value with 1000. So I'll write it here. So E is equals to 1200 divided by 1000, and this will be in kilowatt hour. So the answer is E is equals to 0, 0 cancel. It will be 12 divided by 10, and this I will write it here, 12 divided by 10, and 12 divided by 10 will be how much? 1.2 kilowatt hour. So this is the answer. So this is the answer for toaster. So here energy consumption for toaster is 1.2 kilowatt hour, and here for TV it is 1 kilowatt hour. So these are the answers. So after writing all the solutions, answer you write properly with all the units, and write all in a square box like this. So it will be a neat way to write the answers. Now the next, that is B. 2 ohm and 4 ohm resistors are connected in parallel. So we have two resistors. One has a value of 2 ohm and second has 4 ohm, and we are going to connect it in parallel. If 6 ohm resistor is used in place of 4 ohm, then find the difference between the total resistance obtained in both these arrangements. So first we have to find out the total resistance by taking 2 ohm and 4 ohm resistor in parallel, and then we have to replace this 4 ohm by 6 ohm, and then again we have to find out the total resistance for the new arrangement, and then find out the difference between the total resistance of first arrangement and the second arrangement. So we will solve this. So we will write case 1 first, case 1. Now what are the resistors we have here? First we will write R1. R1 First is 2 ohm, and then we have R2, and that is how much? 4 ohm. And these both are connected parallelly. So we will draw the diagram for this. So here I will take first resistor. This is second resistor. So this connection, this pattern is called as parallel. So this is R1 and this is R2, and this is connected to a battery. So this is your battery, positive, negative, complete the circuit. So this is the diagram for this arrangement. And now we have to find out the total resistance. So what is the formula for total resistance in parallel condition or parallel arrangement? 1 by Rp is equals to 1 by R1 plus 1 by R2. Now substitute the value. 1 by Rp is equals to 1 by R1 is how much? 2 plus R2 is how much? 4. So we will take 4. Take the LCM of this 2 and 4. So 1 by Rp is equals to, so what is the LCM? LCM will be 4. I hope you know how to calculate the LCM. It will be 4. So here multiply by 2. 2 2s are 4 and here 4 1s are 4. So 2 plus 1. So 1 by Rp is equals to 2 plus 1 will be 3. So 3 by 4. So this is 1 by Rp. We want only Rp, and therefore Rp is equals to, it will be reversed. So 4 by 3. And if you divide this 4 by 3 like I am doing here, so see, this is 4 and this is here 3. So if you divide this, 3 1s are 3, so it will be 1 here, take 0, the decimal, 3 3s are 9, and again here it will be 1, again 0, and this will continue. So the answer, that is Rp, is equals to 1.33, and this is resistance. So write the unit, that is ohm. So this is the answer in first condition, first arrangement. So write down the answer in a box. Now we will solve the second case. Now the second case, so I'll write it here, case 2. So in case 2, what we have to do? We have to take R1 as usual. R1 is equals to 2 ohm. But R2, that is 4 ohm, we have to replace with 6 ohm. So R2 is equals to 6 ohm. Again, both we have to connect parallelly. So this is one and this is our second, and this we have to connect it to the battery. The circuit is complete. So this is R1 and this is R2. So we have to find out the total resistance. The formula is 1 by Rp is equals to 1 by R1 plus 1 by R2. Now substitute the values. 1 by Rp. What is our R1? R1 is 1 by 2 plus, now R2 is here 1 by 6. Take the LCM of this denominator. So here 1 by Rp is equals to, LCM will be 6. So write down 6. So here it will be 2 3s are 6, 6 1s are 6. So 3 1s are 3 plus 1. So 1 by Rp is equals to 3 plus 1 will be 4 divided by 6. So we can cancel, 2 2s are 4, 2 3s are 6. So here I'll get 2 by 3. So 1 by Rp is equals to 2 by 3. So this we can write, we can reverse it to calculate Rp. So we will continue here. So therefore Rp is equals to 3 by 2. So divide this 3, how much we will get? Rp is equals to by 2. So 2 ones are 2, 1 will remain, and then here we will take 0, decimal, 2 5s are 10, then it will be 0. So here the answer is 1.5 ohm. So here this is the answer for second case. But the question is they have asked find the difference between total resistance. So I will write. So write down therefore the difference between total total resistance in both cases both cases is equals to. So here in first case and in second case you can see we have got 1.5 here, that is this one, second case, minus in first case we have got 1.3, larger number we write first and then the smaller, and minus it, here we will get 0.17 ohm. So this is our final answer. Write this answer into the box. So this is the solution for this question B. So always remember, as I told, write down the unit for the final answer and even write down that answer in the box. It will be easy for the correction for the teachers. So this is the solution. Now we'll move with the next question. So the next OR question is, here again OR question divided into A and B. So first we will solve A. A 350 watt bread toaster is used 6 hours a day. A 250 watt iron box is used 4 hours a day. So we have here two appliances. One is toaster and one is iron box. So here they have given the power. Toaster power is 350 watt and iron box power is 250 watt. Toaster is used 6 hours a day and iron box is used 4 hours a day. If these appliances are used for 30 days, if both the appliances you are using together for 30 days, then calculate total cost of energy consumption at the rate rupees 4 for 1 kilowatt hour. So what you have to do here, first you have to find out the energy consumption for toaster, then you have to find out the energy consumption for iron box, and these both you have to sum. So we will get the total energy consumption, and then we have to find out the cost for 30 days and 4 rupees for 1 kilowatt hour. So here they have given the power in watt. So find out the energy, convert in kilowatt, add these both the energies and take total, and then for 30 days find out how much will be the cost of energy consumption. So we will solve it step by step. So first we will solve for bread toaster. So I will write it here number 1, and that is bread toaster. For this, what all we have power. Power is how much? 350 watt. And then we have time. Time is 6 hours. Find out the energy consumption. So we know the formula. We have solved in our earlier question. So energy is equals to power into time. So substitute power, that is 350 watt, and the time is 6 hours. So the answer for energy will be, multiply 350 into 6, it will be 2100 watt hour. So this is the answer in watt hour. So for kilowatt hour, we have to divide this with the 1000. So therefore energy is equals to 2100 divided by 1000. And this answer will be in kilowatt hour. So zeros will be cancelled and E is equals to 21 divided by 10, which is nothing but 2.1 kilowatt hour. So this is our energy for, that is bread toaster. Here we will write E1. So everywhere we'll write E1 and we will take E2 for our iron box. So write this answer which we have got into the box. Now we will solve the energy for iron box. So I will write it here too. And this is for iron box. So here again what we have, power is given, that is 250 watt. Time is given, that is 4 hours. So substitute the value. The formula is E is equals to power into time. Power is 250 watt and time is 4 hours. Multiply 250 into 4. So here we will write E2. E2. So 250 into 4 will be how much? It will be 1000. So therefore 1000 watt hour. Again this will be in watt hour. We want in kilowatt hour. So therefore for kilowatt hour. Now divide this above answer by 1000. So I'll write it here. 1000 divided by 1000. Here the answer will be in kilowatt hour. So what is the answer? 1000 divided by 1000 will be 1. So therefore 1 kilowatt hour. Write down the answer in the box. Now we have to find out total energy. For bread toaster it is E1 and for iron box it is E2. So find out the total by adding these two values. So I'll write it here. So therefore total energy is equals to E is equals to E1 plus E2. So we will write like this. So capital E is equals to, what is E1? E1 we have got 2.1 plus, and this E2 we have got 1. So our total energy E will be 3.1 kilowatt hour. So we got here total energy and now we have to find out the cost. For this I will write total cost of energy is equals to, what is the formula? Energy into days into cost. So everything is given. So here energy just now we have calculated. I'll write it here once again. Energy is how much? 3.1 kilowatt hour. And days how much? Days is 30. And cost how much? Cost is given 4 rupees. 4 for, I'll write it here, rupees. 4 rupees for 1 kilowatt hour. So substitute all the value. So therefore I will write it here again. Therefore total cost of energy is equals to, so substitute 3.1 into 30 into 4. multiply this. So 3.1 into 30 into 4 will be 120, and 3.1 into 120 will be 372 rupees. So 372 rupees. So this is the total cost of energy. So this is our final answer. Now the next is, that is B. A fan having power 880 watt is connected to a source of potential difference 220 volt in an electric circuit. Calculate the electric current and the electric resistance of this circuit. So there is a circuit in which there is a fan and a voltage, that is potential difference 220. So fan power is 880, potential difference, that is 220. We have to find out the electric current and electric resistance for the whole circuit. So we will solve it. Write down first what is given. So given, we have power. Power is 880 watt, and then we have potential difference, that is voltage. V is equals to 220 volt. So I will write it here voltage, and first we will find out electric current. So I'll write it first, that is electric current. Electric current. Electric current, to find this, that is the symbol of electric current is I. So we will use the formula of power. So power is equals to V into I. So here we have to find out I. So we will rearrange the formula. I is equals to P divided by V. Substitute the values. I is equals to, so how much P is given? P is 880. So I'll write it 880. And how much V voltage? That is 220. So here 0, 0 cancel. 21 ones are 20, 22 ones are 22, and 22 fours are 88. So here I will be 4. And what is the unit of current? It is ampere. So write answer in a box. So we got current, and now we will find out electric resistance. So therefore now I'll write it here second, and I'll write electric resistance. So according to Ohm's law, so we are going to use here Ohm's law formula. According to Ohm's law, we know the formula, that is V is equals to IR. We have to find out R here, that is resistance. In this formula we have V. V is 220 volt, and just now we have find out that is I. I is 4 ampere. Substitute these values here. So first we have to rearrange the formula. R is equals to V by I. And now substitute the values. R is equals to V is how much? We have got 220. I just now we have got, that is 4. And divide this. So how to divide it? So I will take here 220 and 4. 4 5s are 20. We'll get it here 2, and again we will take this 20. 4 5s are 20, and here we will get 0. So the answer is 55. So R is equals to 55, and the unit of resistance is ohm. So this is our answer. So write down the answer into the box with the unit. So here the answer for B is R 55 ohm resistance and current is 4 ampere. We'll move with the next question. So now we'll see the next question, that is question number 12. Here it is divided into two parts, question number A and question B. So we will start with question A. The question is, state the laws of refraction of light. So here you have to write laws of refraction of light. So there are two laws here. So number one, we will start. The incident ray, the refracted ray, and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. So you can see this diagram here. So this is medium 1, this is medium 2, and this is normal. So if this is the incident ray means what? The light ray which falls on the interface of the media. So this is the incident ray. Once it hits in the on the interface of this medium 1 and medium 2, it get refracted, it get bent. It may bend towards the normal or it may bend away from the normal depending on the medium. So here this is called as refraction. So this is incident ray and this is refracted ray and this is called as point of incidence. So these all lie in the same plane. So that is our first law. Now what is the second law? So the second law is the ratio of sine of angle of incidence to the sine of angle of refraction is constant. So this is the second law, that is sine of angle of incidence to the sine of angle of refraction. This ratio is always constant. So here you can see, if this is the incident ray and if this is the normal ray, then whatever angle which will be present between incident ray and normal, that is called incident angle, and the angle which will form between the normal and the refracted ray, it is called as refraction angle. So sine of angle of incidence divided by sine of angle of refraction will be always constant. And this will be constant for what? For the light of a given color and for the given pair of media. So if you change the ray of a light, this constant will change. Even if you change the medium 1 and medium 2, then also this constant will change. But the ratio of sine of angle and sine of angle of incidence and sine of angle of refraction for that particular light and for the given pair of media will be always constant. Means imagine if the medium 1 is air and medium 2 is water, then whatever the ratio will be there, that will be constant. If you take medium 1 as a glass and medium 2 as a water, then the ratio again, it will remain constant but it will be changed compared to the first medium. So this is the second law. This law is also known as Snell's law of refraction. So this second law which I told just now, that is the ratio of sine of angle of incidence to the sine of angle of refraction is always constant. This is also known as Snell's law. If I is the angle of incidence, R is the angle of refraction, then how it will be denoted? So see here, sine of I divided by sine of R, and this value will be always constant. So this is the way how we can denote this second law of refraction or Snell's law. So this is the answer we have to write for A. Now, question number B. Mention any two differences between convex mirror and convex lens. So read the question properly. Here they have asked convex mirror and convex lens. Actually, in majority of the question paper, they will ask the difference between convex mirror and concave mirror or convex lens and concave lens. But here they have asked the difference between convex mirror and convex lens. So mirror and lens difference they have asked. So what are the differences? They have asked here any two differences. As at least compulsory two differences we have to write. So here it is convex lens and here it is convex mirror. So in convex lens, refraction phenomena occur. So always in lens there will be refraction. But in mirror, there will be always reflection. So here I have drawn the diagram. This is the mirror diagram and this is the lens diagram. So when the light falls on this mirror, it get reflected, get diverged. So this we have to remember for the mirror. So it is reflection. But in case of lenses, when the light enters into the lens, it get diverged, but it shows refraction process. So therefore, the first difference is this. Second difference, in lens there will be two focus. So we know that if this is the principal axis, then there will be two focus. One on one side and the second one will be on the other side. But in mirror, there will be only one focus. Third difference is in convex lens, it is formed by the combination of two mirrors together. So you can see this lens. This is one mirror, that is convex mirror. This is concave mirror. By combining two pieces of mirror, we will get a lens. But in case of mirror, it is just one curved surface. So see this. It is just a one curved surface that is called as convex mirror. So these are the three differences which I have given here. They have asked two differences. If you know three, write down all three differences together. But at least compulsory you have to write two differences. So this is question number 12. And here we have completed part A, that is physics. I hope you liked the video and you understood all the questions, answers very neatly and completely. These all videos will help you to score good marks in your final examination. So students, if you like these videos, then for more such videos, like, comment and share these videos with your friends, and please consider subscribing my channel. Thank you so much.